Hello YouTube, quick video. So I changed my ground blocking diode to this massive 1N5408, and then I have a same capacitor 100 volt 1 microfarad going to this neon bulb, and then I have a 350 volt spark gap there in a bulb that I have in parallel to that. And then basically I took off the overflow from this supercapacitor, so it's not going like that looping. And then I hooked up the scope to this independent coil right here, which is 111 turn number 24 wire around this iron core, uh, which is about half-inch thick here and then 2 inches wide or so. And then I have a little diode coming off of that just to see the positive spikes. And I'm seeing a bunch of this noise here that kind of sparkles about, and I don't know, maybe it's picking up some solar radiation that's coming in through the walls, and it seems to peak out at around zero point 0.6 volts for a lot of these things. They don't go much past that. But maybe this is detecting some cosmic rays. I don't know. You tell me. You can see that standing wave there, essentially. And then if I zoom in, that's at zero point 0.2 volts per division you're looking at right now. And then this is 0.1 volts per division. So you can see it go off the screen with these flickers. If I turn up the intensity, you can kind of see that better. And I'll go to 50 millivolts. You can kind of see this noise here. I just did the time sweep shift with the knob. So we're at 0.5 milliseconds per frame. You can see the wavelength is about across the whole thing right there. And you can see some noise and fuzz in the waves and how there's a little wave generated right after they collide, which is kind of interesting. And then seems like these peaks are consistent, and then these other peaks that kind of are higher than that seem to be kind of in more random spots. And then something that's interesting, if I stick my finger in water, check this negative impulse. See that? Every time I stick my finger in the water, there's a little negative impulse that goes down on the screen. So you'll kind of see a sharp dip there. So I'll zoom out so we can see how big that is. So this is half a volt per division now. Stick my finger in. So it's not a very big dip that's generated. You can see, like, it does have an interesting effect though. So we're back down to 0.2 volts per division. You can see that it went down a little bit. So it doesn't go down too much. And then if I were to take this pot, which is my resistor on this Bendini motor, and I kind of ground my body capacitance to this negative terminal, that's kind of what starts to happen there. Oh, it just, wow, that was amazing. It just arced that far to my body. Uh, that's interesting. I've never had that happen. Uh, wow. Okay, so I gotta be careful. So I'm touching this ground here, and you can see this new waveform when your body capacitance is on that. It's kind of interesting. And then I'll go to like 2 volts per division, and you can see that it's not very big, right? We're at like point, or no, 4 volt pulses or so, because that's yeah, that's about 4 or so. You can see the random negative spikes as well coming off of it. Kind of odd and interesting. And then if I were to zoom in on this again, so we're at 50 millivolts per division. And if I touch this iron ring right here, touch, you can see that changes that. And then if I were to touch where the oscilloscope is, it really changes it. So we'll go to 0.5. So just having the signal in water greatly picks up the signal. If you're doing a coil that's picking up energy that's independent, it seems like. Independent to these coils, right? So yeah, you can see the neon bulb is very lightly flashing, and I have no idea if this supercapacitor is charging effectively, and none of our LEDs are lighting up at all. But we don't see any spark here. So I thought it was really interesting how it arced to my body across multiple inches, even though this neon bulb isn't very bright or anything, and it didn't really hurt, but I felt it, and it was definitely there, and it was a big distance to cover. So I figured, what happens if I take the ground of this pot, essentially, and I take the ground of this DC side, and I touch them? Whoa, that was a big flash in energy on that current on that Bendini motor. And you can see the neon bulb flash brighter too. And then check out the LEDs now. See them light? Now I'm going to show you the oscilloscope. So it's sucking up all that noise. And I have no idea what that did to the supercapacitor, or if I should not do that, because it seems like a lot of current starts surging into the Bendini motor. But it did shock and spark that time a little bit. It was a little tiny red spark. I don't know if you saw that. So the reason why this capacitor wasn't charging earlier, if you've been following my videos, is essentially because this ground wire wasn't grounding very well. And as soon as I took this grounding wire and stuck it in this water, this capacitor was really able to charge up. And now both sides charge. And I've been messing with the ground, as you can see, as today's experiment with over there. So um, this is the ground of our 1K potentiometer coming off of our Bendini motor right here. And so I've connected the ground not only to the negative DC uh, ground terminal side of the full bridge rectifier, but essentially I have it connected to the DC ground side over here as well. And I think I actually have my ground on my water connected to the wrong thing right here. It needs to be connected to this AC side. But anyways, that's how I've been experimenting with it for now. And basically what's interesting, my battery is at around 14 volts or so, it looks like, maybe 13. I don't know, it's kind of hard to tell. We're on the 50 volt mark. I've been kind of using this as a blocking diode on my ground. This is like the primary coil loop, and so as you can see, my input energy goes through this electron avalanche into this primary coil, which is 300 turns. And so I've kind of tried connecting this ground to different spots and had some interesting effects, different glows of plasma. And I also found that if you basically have this here, I can even just have this here, just sitting there, and kind of the swing method that Tom Bearden talked about, where you pulse this, kind of needs a loop to get started, it seems like.
But if I were to clamp this on here, it's kind of difficult.
And then I basically pulse that, you kind of see that. This kind of jumps every once in a while. So you can hear me switching. Sometimes it doesn't jump, but sometimes it does jump. Oh, by the way, this was the 10 volts per division, so it just jumped 5 volts like right off the rip. Um, so we're at the 2 volt mark doesn't really work. None of them work proper, it seems like they kind of all measure a little bit off inconsistently. And I notice it does kind of dissipate in energy and discharge over time unless you swing and pulse it at a rate that builds energy faster than it dissipates it. But I just switched it, and you can see it kind of pulse up. It's more obvious on these smaller marks here. So I'm just pulsing the Bendini motor on and off. I'm not quite getting the good timing to make the effect. Anyway, so we'll try turning it on and spinning it, and you can see this just shot up, and we're already at the maximum voltage that basically the circuit can supply to this, because essentially, as Joel Gase has shown us, and I have shown you in the last video, the voltage when you loop it is limited to the source essentially. But you can see that we got a solid amount of voltage with like 10 volts or so there, and this is some real power here. As you can see, it actually momentarily kind of welded right there to that copper and pulled it off, as you can see that black mark. Um, so I'll go ahead and put that on again. Go ahead and check this other side just for the heck of it. So a lot of energy there too. Um, so that's kind of cool that that side's working now. And then, so we'll go ahead and ground this to something else maybe. Like if I were to go to this ground. So nothing happens when it's off, but when this system is on, this ground surges into this ground. So let's turn this on, and basically we'll just leave this ground hanging for now. Maybe hang it on there. I don't know. So it doesn't go up very much, but it does go up. And here's the ground. Now I'm gonna touch the ground here. You really see the difference, right? And so you can see it really go up when I touch it. So I'll go to a different. So I'll go ahead and touch it again. You can see it really going up. And so right now we're at like a few volts. Now I'm going to touch the battery before it gets too much. It like welded almost. It's smoking right now. It's wild. You see this water drip out? You see that little water drop? It's literally condensing water. So what if this ground can actually pulse into the motor, you know? So it doesn't really do anything there. But when it's off, it has this interesting effect where touch the ground, nothing, touch the positive. Whoa, look, it's off, but we're running through this diode from this positive because it doesn't block all the current. Kind of cool. So I've never powered something through the ground like that. Kind of interesting on this Bendini motor. And then I touch it back to this. I had a big discharge and arc here. This wire is getting pretty hot, so I'm going to stop doing that. But as you can see with the battery voltage, I don't know, it looks to be the same. It hasn't gone down noticeably at all. here we are on our measurements, which don't really align depending on the volts per division. But let's see if there's some real energy here. I bet there is, even though the oscope doesn't really measure it very well. So definitely some real energy there, even powering it in an unconventional way from the ground. Well, I guess the power was, in theory, still coming from this battery. This doesn't block all the current, right? And so some current still gets through. But what's interesting is the way it's going through the ground and powering it. It's just strange to me, but it's so cool. Um, and then let's connect the ground to basically the full bridge rectifier ground. Okay, so we discharged that energy, so we're kind of like reset. We got this ground on the negative DC side of the full bridge, on this side at least. Still got same voltage. Gonna pulse it on. Whoa, that's odd. So 0.2 volts per division measures nothing. 0.1 volts per division measures 0.2. 50 millivolts measures nothing. Oh, now it measures nothing on 0.1. I don't get it. Oh, now it's off the screen. Is it broken? Okay, well, that's odd. But it's like really magnetically like locked up and like really surging with current. And that's just putting the ground on the common ground of the DC side. So it's almost like it's sucking charge from this supercapacitor, or current. It's making a bunch of current. I feel like I'm destroying this thing. These neon bulbs sure are black. I had to change this one out this morning to start experimenting because that was just too beat up. So, nada. So I just broke my oscope, I guess, by having my ground connected to this lead. I think the backflowed through this, fried something in there and killed it. So don't do that. Okay, so this time I attached the Bendini motor ground to the literal earth ground. I have a wire going outside my door, literally into the dirt. And yeah, I have no idea what this will do. I just broke my oscope, so let's just... So it turns on like normal with the Bendini motor. We're on max resistance on the potentiometer there. And it seems to have a pinkish glow on the neons. And as you can see, these red LEDs are lighting up. So I'll turn this off so you can really see that glow. So all these LEDs are lighting up. The LEDs right on the supercapacitor there isn't, even though it's attached to like the same parallel wiring. Kind of interesting. As you can see, I added this second neon bulb a while ago to this Bendini motor from K Energy. I showcased that in an earlier video, even though I didn't say it. Just noting it. Lights off for visual effect. Some sparking there. A lot less sparking this time, now that we're connected to this earth ground, instead of basically connecting the ground to this negative side of the full bridge, which is the common ground between the potentiometer. Um, and when I connect it to the battery ground, man, this thing goes wild. Okay, so this time I essentially connected this ground to the negative terminal of the battery as well as the common ground from this potentiometer. And I might have to add another blocking diode there going in this direction. Maybe I should turn that one around. Um, but for now, we'll just try this. So definitely a lot of current flowing through that ground and instantly started smoking and shorting things. So as you can see, the ground is a vacuum pump, and I hope I didn't destroy things to demonstrate that. So hopefully that didn't destroy it. I reversed this diode right here and made it so, hopefully minimal current will go into here. Looking at the voltage here, it looks about the same. Maybe it went down a little bit from that, honestly, it looks like, which was just a quick moment, but that's all it took to make it go down a bit. So we'll just flicker this on, see what happens. So the neon flash, nothing smoking so far. It seems to work okay like this. And I have no idea how quickly this is generating energy over here. So our potentiometer is on max. We'll turn this off, see how that did. I'm kind of using these supercapacitors, discharging them as a visual indicator with how big these sparks are to see our effectiveness. But also I'm obviously using them in the circuit, right? So no energy here on that supercapacitor and no energy there. So the Bendini motor can turn on like this, but it doesn't do anything when it's like this. And then another way I can test the ground with this blocking diode with this Bendini motor to this negative side of the primary coil, also connected to the common ground of the DC and the negative terminal of the full bridge, as well as the ground of the pot. And haven't quite configured the grounds like this yet, so nothing smoking, things seem to be running. The LEDs are on in this configuration. Pink glow. We'll just turn that off. And then we'll use this to see our effectiveness. So nada, nada. Hello YouTube. So playing with the ground produced some anomalous effects. So essentially one time I had the ground with this wire, this diode, but this wire was on this side of the diode, and I just touched it to this ground trying to link it, and it like arced to it and started smoking all of this. Everything flashed and immediately started burning up, so I pulled it off of it. That was an amazing amount of energy just connecting two grounds together. That was kind of an interesting experience. And then next I decided to see this side of the diode connected to this ground. And that seemed to prevent a lot of the like backflow and allowed the Bendini motor to run normally, but it didn't seem to effectively charge the capacitors at all. So then basically next what I tried is just connecting this ground wire instead of this side of the full bridge to the water, and that seemed to stabilize things to where the Bendini motor kind of dimmed out and sped up at a certain point, which was different and interesting. And then basically, what I've done now is I've taken a little small cap bank, and because of that anomalous effect with all the energy connecting the grounds, I was like, and I was touching back and forth, back and forth, and it was like able to spark from the ground. So I was like, okay, that's interesting. And my battery seems to be like doing just fine, maybe even gone up a little bit. And so I was like, well, maybe I can capture it with a super cap bank like this. Um, so we're connected to the negative side of this. So I'm hoping that, this creates kind of like a suction effect. And so the Bendini motor is off, as you can see. We're around 14, 13 volts or so. Um, and then you can see this kind of arc. So I don't think this is the backflow, the leakage from the Scotchy diode. And then check this out. So if I get kind of both in view, excuse me, get both in view and keep an eye right about there at that bulb when I spark this. But this time I'm going to spark this side of the diode. And it kind of, sorry, get it to focus back there. See that? See the bulb glow? So this is off. So that means the only way it can get there somehow is going back in reverse through this diode. But as you know, it's going through this diode, and it can't really go through this way. So somehow energy is flowing interestingly in here and or in here as a suction pump and leaking through this diode because this switch is on SG mode, schoolgirl mode. If I were to switch it to generator mode, oh shit, I melted this switch. Oh, sorry, excuse my language. Um, I guess there's a lot of energy because I melted the switch earlier when I arced this over here. Okay. Um, Anyways, let's just go back to this and let's just spark this. So I've noticed this is acting as a spark gap and I'll generate different colors depending on the proximity. You can get it to arc and it'll weld itself on there, it keeps sticking. And then once again, I'll do it on this side. If I do it quick enough, you don't even see the light bulb. But if I do it slow enough, you can see it happen. Kind of interesting. So I wonder if this can be the tap you can just keep tapping off of and discharge this instead of into your source battery, into like a battery bank, a separate battery bank or so. But yeah, I don't know if this is charging it or not. It seems like it does need a little bit of time to build up charge again if you do it too fast. And it seems like it likes a certain rate and distance away. One time I generated a really good green flash. That was a good one, I guess. So essentially I want to see if this is leakage from the battery through the diode. So I just disconnected and I'll touch it so it discharged. And I wonder if it will keep doing it. Nope. Okay, one last little experiment. So basically, I did find out that it was leaking through this diode to charge this, so it wasn't sucking in that instance. But that arcing between the two grounds with that one configuration when it was off camera, that was so odd to me that I just couldn't get it out of my head. So I started touching around with this with the negative and positive leads, and I just want to show you the effects. So this is the negative lead going to the negative terminal of the battery, and you can see that one of those neons goes off, that turns bright, and this one goes off. Kind of interesting. So now I'll touch this same negative lead to the positive side. Zoom out a little bit so you can see that one too at the same time. Wow, that's bright. So I notice this one's the brightest, and it starts bogging down. These two both remain on. This one lights up, but this one turns off. Notice that the whole point of this is a phase delay. Okay, so now we're going to take the positive lead of this little capacitor bank I have here, and then I'm going to do the same thing. So we'll touch it to the negative side first to repeat a similar pattern as before. So positive cap bank terminal to negative battery terminal, also lights it brighter, turns off that one and that one. But the most bright was either the impulse of the positive at the very, very beginning, and that turns off that, bogs it down, turns off that one, and keeps that one on. But I honestly kind of feel like the negative to the positive is even brighter, and it keeps both of those on, which is kind of interesting. Um, so yeah, tell me what you guys think. Um, so our multimeter is down to 0, I guess. Turn it back on. Maybe it's just not touching it well. Oh yeah, it just wasn't touching it. So we're at the same voltage. And as usual, we'll just finish off with a nice little discharge. That one looked more blue. This one too. That one looked more red. Maybe it's how close I get, how quickly I get there when it arcs that makes the color. I'm not really sure.